Hi, welcome to lesson 32, session 1. Today we're going to be taking all the work we've done so far with coordinate planes, and now we're going to be figuring out how we can represent problems in the coordinate plane. So now we know how to make a coordinate plane, we know how to label the x-axis, the y-axis, we know how to find the point of origin, and so now we're going to go, okay, and we also know how to find ordered pairs and how to move around with those ordered pairs. So now we're going to look at some real life problems and figure out how could we use a coordinate plane to help us answer mathematical problems. So we're going to be working today in our Ready Classroom Math Workbook on pages 659 through 662. So go ahead and turn to page 659 in your Ready Classroom Math Workbook now. So previously, we learned how to locate points in the coordinate plane. We're going to use what we've learned to try and solve this problem below. On the graph below, points S, M, and B, are three vertices of a square. Plot and label the fourth vertex, G, of the square. What are the X and Y coordinates of G? How do you know? So first of all, we are going to be graphing below, and we know that we are trying to make a square. So first of all, what do we know about the qualities of a square? Well, we know that a square has four equal sides. You might have also said that a square has two sets of parallel sides. You might have said that a square has four right angles. You might have just said a square has four sides. But the important part for this particular problem is that a square has four equal sides. So now, after we know that a square has four equal sides, we need to plot and label the fourth vertex, or the fourth corner of the square. So how might we do that? So some people might go, okay, well, let's look at point B and point S and kind of move until we collide. Yep, that's one method. Not super scientific though. So I think a better method would be, we know that all the sides are equal. So let's go ahead and count how many units it is from point M to point S, because I imagine it will be the same number of units from point B down to point G. So from point M, we're going to count how many units there are. There is 1 unit, 2 units, 3 units, 4 units, 5 units. So we're going to move our point B, we're going to go down 1 unit, 2 units, 3 units, 4 units, 5 units, and we're going to put a point on that location, and then we're going to label that point G. Point G. So now we've plotted and labeled the fourth vertex, which is G. Remember, vertex means corner. It's like the corner of the C-O-R-N-E-R. The corner of the squares are called the vertices, but one is called the vertex. Now, what are the X and Y coordinates of G? So remember, when we draw an ordered pair, we use parentheses. The values are separated by a comma. The X value always comes first, and then the Y value comes second. So for point G, we're going to see where is point G on the X-axis. So if we drew a line straight down from point G, where would it intersect with our X-axis? Remember, the X-axis is the horizontal axis. So from point G, we would go down and see that we have an X value of 8. Then we're going to take point G and do the same and draw it all the way over to the y-axis. And we're going to get a y value of 5. So point G is located at 8, 5, because the x value comes first, the y value comes second. And we know that because that's just what we know. We've been doing this for long enough that we know that that's how it works. All right. Let's go ahead and go now to page 660. 660. So Looking back, it says explain how you determine the ordered pair for the fourth vertex G on the square. So remember what we did. We know that all the sides of a square are equal. And so what we did, all the sides of a square have the same length. So we counted one side and then made sure the other side was equal. And that's how we knew that we had, in fact, put the point where it needed to be. Now, looking ahead. On the previous page, you solved a problem about a geometric figure graphed in the coordinate plane. We made a square. A coordinate plane graph can also be used to show relationships between two real-world quantities. So on this particular coordinate plane, we see this problem, or this word problem, the data from this word problem. Mia works as a dog groomer at a pet store. The coordinate plane shows the relationship between the number of dogs Mia grooms and the number of hours she works. So if we look at this title down below, we see the x-axis is how many hours Mia works. And then the y-axis is how many dogs that Mia can groom in that amount of hours. So if Mia worked for 0 hours, she would groom 0 dogs because she didn't do any work. So she couldn't have groomed any dogs if she worked for 0 hours. If she worked for 1 hour, she could groom 2 dogs. 2 hours, 4 dogs. So let's go ahead. I don't want to give you away too much. So let's see what part A says. Use the titles on the axes to explain how to interpret a point on the graph. So the x-axis tells us how many hours Mia worked. The y-axis tells us how many dogs she groomed in that amount of hours. So if you could use this for quite a few, to find quite a bit of information, and we're actually going to do a couple examples now. So how many dogs did Mia groom in 4 hours? How do you know? So if we want to know what is the information that we know that Mia worked for 4 hours. That's the information we know. What do we want to know? We want to know how many dogs did she groom in that 4 hours. So if we know she worked 4 hours, should we start on the hours worked or should we start on the dogs groomed? That's right. We're going to have to start with our 4 hours. So if we move on the x-axis over to the 4, this is when Mia worked 4 hours. Then we're going to follow the line up until we get to our point. And we can see that this is where we get to the point where with the number of dogs that Mia groomed in 4 hours. How many dogs could she groom in 4 hours? That's right. She could groom 8 dogs. So Mia could groom 8 dogs in 4 hours because the the y coordinate, I want to use the right word, the y coordinate is 8 when the x coordinate is 4. So the coordinate would be in 4 hours, Mia groomed 8 dogs. That's what the ordered pair 4-8 means. In 4 hours, Mia groomed 8 dogs. And then we can even write that right here. 4, 8. So what do the coordinates of the point located at 3, 6 represent in this situation? So if we go over to 3 and up to 6, they want to know, what does 3, 6 mean? What does that tell us? And what that tells us is the 3 means Mia worked for 3 hours. The 6 means how many dogs she groomed in those 3 hours or in 3 hours. So that's what the ordered pair 3-6 means. She worked for 3 hours and groomed 6 dogs. So if we look at the reflect, what are some of the differences between the graphs in Try It and in problem 2? So in Try It, as you can remember, we made this square in Try It, okay? In number 2, we graphed points on the graph, and we made a line. So the graph in Try It made a square. The graph in problem 2 made a line. So even though we used a coordinate plane to do both, we got 2 different types of answers. As soon as you've got that down, you can pause it until you're finished, and then you can move on to page 661 with us. We've got this awesome little graphic organizer that gives us just a little bit more of an understanding about coordinates and what we know about what coordinates are and what we know about them. So what are coordinates? They are the numbers in an ordered pair, often represented but with the x value first, the y value second, that describe a location of a point on the coordinate plane. We know that the x shows how far you are from 0 along the x-axis, and the y shows how far you are from 0 along the y-axis. So an example of coordinates, this point here would have an ordered pair of 5, 2, and the 5 is the x coordinate, and the 2 is the y coordinate. We can show the coordinates just as an ordered pair, and we would know, because we know that this is the x value and this is the y value, we would know how to put that on a coordinate plane if we were working on, if we had to put this point on a coordinate plane. Or if we're just given a point on a coordinate plane with a letter value, we can figure out what this point A is by looking at the x value first and then the y value second. So we know that point A is at 3, 4. You're going to go ahead and pause the video here to make sure that you get this all written down. You're going to go on and do page numbers 2, 3, and 4 on your own. If you have any questions, you can always email your teacher. Otherwise, we'll see you next time.